I can't make new memories. Everything just fades.
What's the last thing you do remember?
My prompt asking if 10 duck-sized horses could defeat one horse-sized duck.
When I first started learning LLMs, I made smooth progress. Sure, I was only scratching the surface, but things generally clicked in place. Basic prompts, and then RAG, and I figured chat memory would be the same.
In and out, 20 minutes adventure.
Instead, I fell down a bit of a rabbit hole. You see, chat memory, conceptually, is easy. You just pass all of the previous messages along with your current message, and that's it. Conceptually. Implementing it well, though, is another thing, especially when you try to get it to play nicely with RAG. We'll get into that shortly, but first, let's take a sneak peek at what we're building. As a reminder, we're local only, open source only, offline, no API keys. At the simplest, you could save the chat message history out to JSON and then read it back in. And that would work, until it doesn't. What if you want to have multiple conversations? Or what if you want to have multiple users? Or what if you want to see all the messages from a given user? Or generate a chat summary? This approach of serializing out the messages has a very short ceiling. And for that reason, I'm not going to code it out. Instead, we're going to treat this like a proper, albeit proof of concept, chat app. Since we're just trying to learn the concepts, we're not going to make a full-fledged production-ready app. We'll continue to bolt things on, but if we had the goal of making a production-ready go-live app, we do things a little bit differently. We're not going to cover user management, authentication, authorization, deleting users. All that stuff's pretty standard web dev, and it doesn't really further our understanding of LLMs or machine learning. Also, we're not going to refactor the content management. Ideally, we'd use the DB to store the content, not the file system, but then we'd end up writing a full CMS, and again, that doesn't really further things. Now, there's going to be a bit of a jump in complexity in this part compared to the previous ones. And even then, we aren't at the fully realized form. You see, we're on the cusp of being both hardware constrained using our CPU and paradigm constrained using simple LLM calls. After this point, we'll likely need to spin up a compute instance and dive into the world of agentic AI. For now though, let's carry on as is. Our toolkit for today. It's going to include everything from last time, plus Postgres for our DB. We're going to be using SQL Alchemy, specifically the Flask version for our ORM. We're going to use Flask Migrate for our DB schema migrations. We're going to use SQL Alchemy Serializer to help with our JSON serialization. We're also going to wire up some CLI commands and a simple logger. And lastly, type hints, because like I said, we're getting complex enough to where we're going to need them. All right, let's go ahead and dive in. We're picking up where we left off, but let's do some cleanup real quick. First, we're going to clean up our Infinity Docker config. So we can see here what we've done is, if we take a look at the diff, we are going to specify our embedding model full name. Infinity expects this format because it's going to pull it from Hugging Face if needed. So we've got that. We're going to point directly at the Infinity image now, and we're going to invoke it directly. So we're going to pass in our model ID, which is again going to be that full name, and the port we're going to listen on. And lastly, we're going to use version 2. So that means we can get rid of this customized Docker file that we had before. So let's go ahead and commit that. Next, we're going to make sure that our natural language toolkit is installed properly. I think for the last couple times I had it cached in the volumes, and then when I tried just doing it from scratch, I noticed that there were some issues. So taking a look at our entry point, we're cleaning this up. This is again what gets run in our web container. So let's look at the tree. So we're in app, we're in our Docker file. This is what calls entry point. So what we're doing here to clean it up a little bit, we're going to drop 3 from Python because that's the default now. It'll point to Python 3. And then we're also going to run the import natural language toolkit and then download this set of libraries. This will just ensure that it's able to process it correctly. And again, this is only going to run the first time. So let's do that. Next, we're just going to do some more cleanup here. Okay, here we have some cleanup for our Docker Compose and Docker. Previously, we were just kind of using a simple Docker file for our app. We were running it as is. So this would actually run it as root. So what we're going to do instead is now run it as a user that we create during the Docker file build. So we're just going to call it app user. We're going to set the working dir as /app. We're going to create a group and user for app user. We're going to set the working dir to /app. And then we're going to change the ownership of this working dir to app user. And then you can see here we're switching to that user, and then we're just changing our entry point a little bit to be in that correct directory as opposed to what we had before. In our Docker Compose, the only thing we're changing here is just, again, pointing it to the new working dir. So let's go ahead and commit that. Okay, so now we get to dive in to the real deal. It's going to be quite a few changes, and we'll go through it step by step. As I mentioned, we're going to add the Postgres DB. So you can see in our environment file, we're adding quite a bit of config options. So we're going to use the Postgres adapter. We're just going to use some simple placeholder config. So hostname is just going to be DB. This correlates to what Docker has in the compose file. The port, we're going to prefix it with 1, but use the default. So 5432. And again, just some simple stuff for the creds. We're also, because we're doing a lot of these back to back, I am going to use the host Olama as opposed to the container. It just makes it easier to have the model weights cached in one place as opposed to per project. So it just makes my setup a little easier. So you could do it, again, going back to the container. We're going to use it on host for now. And we're using phi3 again. That's it for our environment file. Git ignore is gonna ignore this logger. We'll come back to that. We just want a simple logger set up so that we can take a look at things. It's helpful for debugging, especially as we get into more complicated prompts. We can just see what's actually being sent back and, well, not back and forth, sent to the LLM. Our Docker Compose file is a little bit different. So we're going to depend on the DB now from our web container. We're not using the Olama container anymore. So WebDB, pretty simple. We're just using Postgres. We're using the Alpine derivative since we don't really need to do anything fancy, and that keeps it a little bit lighter weight. We're going to pass in some environment config. We're going to map the volume, map the ports, and then we're going to do a simple health check, which is just going to run PG as ready. And then that way we can know that when we're depending on this, it'll only start the web container once the health check runs correctly. Commenting out Olama because we're running it on the host. And that's all that changes for that. Our README is going to have quite a few things in here that are new. So the SQL Alchemy, as I mentioned, we're going to need to run a few commands the very first time we set it up. We're going to, in this case, we're going to generate the migration. You wouldn't actually have to do this if you're pulling it down. Generate the initial migration, run the migration, do any DB upgrades, and then also seed. So DB seed, you'll notice that it's underscored. This is our own command. It's just helpful to generate some initial seed content. Since we're not going to be doing any user management or chat management, it's just helpful to go ahead and put some user one, chat one stuff in there. And then from there, we'll be able to create chat messages. And then this is just a one-liner that you can copy and paste in to do all that. Our app is looking a little bit different. And actually, let's go ahead and take a look at our ERD, our schema. So before we dive into the code too much further, because I think having the ERD on screen will be really helpful. So we're at a point now where we can go ahead and do that. So as usual, npm I, let's just make sure that's all good to go. npm run and copy env and Docker. Okay, our container should be running now. we see the debugger pin, and let's go ahead and we'll run those commands from the README just to kind of give you a sense of what it would look like. So I'm going to copy this one-liner and it'll wipe everything out and then rebuild it. So drop the schema, create the schema, remove the current migrations. Again, you wouldn't have to actually do that. Generate the migrations again, run the migrations, and then see the DB. So it's dropped it, generating the migrations again. Okay, now it's running those migrations. This will create the tables, but none of the content. And lastly, we're going to see the DB. So you can see here, our script put out created user and created chat. So let's pop in and take a look at the schema. I'm using an app called Table Plus to work with the DB. It's pretty nifty. It has a free tier that I'm using, and we can see here our tables. And let's take a look at our schema. So I'll go ahead and do generate diagram from select items. So we've got our users and our chats are kind of the base records. A user, if we do this, is going to have some foreign keys pointing to it. So a user can belong to a chat via this join table. So all it is just a join table. It's not really meant to be used directly. It's just a participation record. So you can say this user belongs to this chat. Also, we've got chat messages. So a chat message is created by a user, and then it also belongs to a particular chat. So nothing too fancy there. I'll also point out that we've got an internal ID and a UUID, as well as created and updated timestamps for pretty much everything. This is just something that I've found helpful in my app development days, to have both an internal ID for incrementing and then a public-facing UUID so that it doesn't leak the underlying details. And then created and updated is always just helpful to have. Right, so chat message is pretty simple. It's got a body. It's got a role that's actually going to be enumerable. We'll look at that in a second, but it's specifically, it's not just a string. There's a predefined list of possible roles. And likewise, those foreign keys we talked about. And then the only other thing is a chat summary. So a chat summary, it points to a chat and a chat message. So what it's saying is likewise, it's got a body, and it's going to look at a chat, and then it's going to figure out what is the last message in the chat and summarize all of the messages at that point. So let's say you have 2 chat messages in a chat. There's the initial user and then the system response. So that's 2 messages. So what we can do is generate a chat summary. It'll say last message ID is 2, meaning it's going to incorporate the previous user message and the last system message, generate a summary for it, store that. And then what you can then do is, as it gets a little bit more complicated, you can replace the chat message history that you're sending to the LLM with that summary. And then again, all it's doing is just whatever messages are at or before that summary, you swap out, and then any messages past that are put in as would be expected. It's a way to handle the context window limits and some other things. And the design of this is such that, again, if the summary is stale and there's messages newer than when the summary was last generated, that's fine, right? Because if there's a 3rd and 4th message and this is only relevant up to message 2, you're only replacing the first 2 messages. And also the idea is, in theory, you could generate this asynchronously, offline in like a batch job. Well, offline in the sense of it's not blocking the request response. You could do this in the background, I should say. and just again, whenever you have compute available. And that's the basic structure for this. So users, chats, chat user join table, chat messages, and then chat summary, which is a derivative of the chat and chat messages. Cool. Okay, let's take a look at our seed data. So again, right now, the only thing we have in here is just one chat, one user, and then the user belongs to that chat. If we were writing a full app, we would, have some sort of a sign-up flow and allow users to create chats. But again, we just want to look at the concepts. So if we go back to our diffs, we're actually going to take a look at our requirements real quick. So our requirements look a little bit different. We've still got Flask, we've still got all that other stuff because we're bolting it on. But now we've got Flask Migrate, we've got SQL Alchemy, we've got the PsychoPG. This is the driver, and we're specifically using the binary version, and then this serializer package. That's just handy to be able to take these chats and ORM records and help turn them into JSON. So let's take a look next at our config. The only thing we're adding here is the database config. So we're going to have entries for all of our environment variables. And then we're also going to have an entry to kind of jam this all together in the format that SQL Alchemy expects. So we're using the Postgres adapter, and we specifically have to say PsychoPG without the 2. We're on PsychoPG 3, which is the more recent version, more performant version, but 3 is known as just PsychoPG. PsychoPG 2 is with the 2. Then we're also, again, appending all of the config in here. So this will just be our connection string. We have a database file that just sets up the initial database connection. So we're just going to init it, and we're going to derive from the declarative base class in SQL Alchemy and init the migration handler, and that's pretty much it. Models. Okay, our models are a little bit more interesting, and I'm actually going to hop out of the diff for this since it's all brand new. So if we take a look at our models, so we're importing quite a bit, but let's run through it one bit at a time. So we're setting some constants here. This is used for the serialization. Our serializer package allows us to define some properties that we can then use when we serialize it. So we're going to use ISO 8601 for the created and updated format. That seems to work pretty well on the front end. We have got our enum, our enumerable, for assistant, system, and user. Let's dive into some API docs real quick. Specifically, the API endpoint we're concerned with is Olama's chat completion API. And this is pretty closely mirrors in I think a more recent version, they actually have an open API endpoint. But for now, we're using just chat completion. This pretty much mirrors what OpenAI's API spec is. So we're going to pass in model. That's standard stuff. The messages that are going to be used to provide the history. And then the role here. So this is what we need to keep an eye on. So system, user, or assistant. So we're just going to map that like this. So user is pretty obvious. Assistant is going to be the response from the LLM. And then system is, again, going to be our system prompt where we kind of set the ground rules. So that's what we have here. So we're going to say that a chat message can be one of these 3 types. And this closely lines up with OpenAPI's spec. So if we take a look at a chat completion on OpenAI, we can see similarly, right, system, user, assistant. And they have some other stuff, but for now we're just focusing on these. And you can see again, it's messages is just an array of messages. Conceptually very easy, right? Okay, we've got some mix-ins here that we're just, since we're doing this for pretty much all of our models, it's just easier to kind of create a mix-in and then use those. So ID, we're just gonna have an ID and a UUID. So this is gonna be an int, this is gonna be an actual UUID, and nothing much there, right? No default, primary key true. UUID, create a UUID version 4, and then ensure that it's unique. Timestamp is what we're using for created and updated. This is right here, datetime underscore format. This is specific to the serializer package. This is how we tell it to always use this format when it gets serialized for these properties. When I was creating the format, so we're using the somewhat standard ISO 8601, %Z was not working as expected, so I'm just coding it out like this as +0000 for UTC. And then we're just saying that you should use, it's essentially the 8601 with time zone format. Again, in my development, it didn't work as expected, so I had to spell it out like this. Then we've got created and updated. These are, again, just our timestamps where we're going to use datetime, not timestamp. We're going to use our datetime for these, where we're just saying it's a UTC datetime object. Created gets set once, updated at gets reset every time the record gets updated. Then we've got our base model. So we have got quite a few things here. We've got our DB model. We've got ID mixin, timestamp mixin, serializer mixed in. And this is just our base model that the other records types are gonna extend. Okay, so user, standard stuff, username, nothing too fancy here. Non-nullable, unique, up to 50 characters. Nothing too interesting there. The relationships, these are important to dive into. So in SQL Alchemy, like other ORMs, there's two parts to a relationship. There's the foreign key component, which is encoded in the database. And that's going to say this record points to another record. So our user does not have any foreign keys on it. Chats and chat messages, well, chats is special. Chat messages point to a user. Chat messages have an actual foreign key column on it called user ID. So a chat message will actually point to a user and it'll say, this is my owner. Users, on the other hand, don't have a foreign key column, but we still want to be able to express the bidirectional nature of that relationship. So in our ORM records, we're going to have a relationship field that isn't in the database, but it's still in our application code. So taking a look at chat messages, we'll get to chats in a second since it's a little bit different, but taking a look at chat messages, we're going to see there's two parts to this relationship, and I'll pull up both. So a user has chat messages that belong to them. So we're going to see that this is a list of chat message and its relationship. And this back populates is a little bit funky. We'll get to that in just 1 second. So we're going to say it's a list and we don't care about representing it when we display it. So back populates. This took me a second to kind of get the syntax. Back populates, even though it's defined here on the user, it's actually relating to the other end of the relationship. So let's take a look at user on the chat message. So over here, we've got chat message. Over here, we've got user. So it's saying back populates user. So we're in chat message. Let's look for the user property. And this is what it's saying is this chat message, user.chatMessage is the other end of chatMessage.user. You see here? Right, so back populates user, that points over to here. And then likewise on user, on chat message, back populates chat messages. So this is how we're doing the bidirectional relationship properties. Okay, so back populates, even though it's defined on class A, it's actually just saying where class B is. Now, if we take a look at chat message, on the other hand, we've also got the foreign key column. So anything that's going to have a foreign key is going to have both the ID property that's in the database, but then also this relationship property that's used for your application code. And you can see here, when we're expressing it, we've got ID, we're saying it's an int. The reason why it's optional on chat message is because when the system generates a message or a response, it's not actually tied to a user. So that's why it's optional. But we've got a foreign key of user ID, and then we've also got the relationship, which is done in code. So we've got the user ID, which is done in the database, right? User.id, that's a foreign key. And then we've got the relationship, which is done in code, which again points back to the user. And we can see that because it has a foreign key property, we're able to specify that here. Still with me? Okay, so users have chat messages, and again, it's a bidirectional, although the foreign key lives on the chat message because it's saying that as a chat message, I belong to a user. Chats is handled a little bit differently because we have kind of a two parts of this relationship. There's many to many potentially, although we haven't implemented that. In theory, a user could belong to multiple chats, and chats could have multiple users, potentially, if this were a proper chat app. So that's why we have to use this join table. So we can see here that we have a property called chat on our user. And then our chat model has a property called users. But they're not actually, there's no foreign keys here. Instead, we're going to use a join table where all it's going to do is have two properties, chat ID, user ID, both foreign keyed, and then it allows us to just kind of hop through that table and express that many to many. Similar syntax aside from that. So we've just got chats. We're taking a look at user. They have chats, and again, they back populate on the chat if you look at users. So this chats property is the other end of this user property. And the only difference here is that we have to have this secondary argument that just tells us what table we have to get through to get to it. So if we take a look at chat user, right, we've got this foreign key, and that's how we get through to it. It's just a join table where you join chat and user. We're also going to use a composite primary key here, where it's just a composite of the chat ID and the user ID. I went back and forth on this. That's what we're doing for now. You could have individual IDs that are auto-generated, but for now, it's just a join table with chat ID, user ID. Okay, so for our user, then we've got those relationships. Serialize rule. This is part of that serializer package that we're using. All it's saying is just when you serialize this out to a dictionary, don't include the chats and chat messages. The reason for this is because it's a bidirectional relationship. If we do include it here, then it's just going to endlessly infinite recursion, where it's like a user has chats, okay, and then that chat has users, that user has chat. So it just kind of goes out of control. So we will include these elsewhere, but for this particular property, we're not going to include any of the relationships. So that's what this syntax means. Minus chat messages, don't include it when serializing. And then lastly, this representation or repr. All it's saying is just, if you want to see the string representation of this, here's how you do it. And actually, that was here. So when we did our CLI command, which we'll take a look at, you can see this is just our string representation. So it's a user class and specifically name, ID. Cool. Chats, let's keep rolling. Pretty simple as well. We've got a title. We've got our users that we already talked about. And then we've got some other relationships. So we've got chat messages, which is a list of chat message. And similarly, we are back populating from chat. So the foreign key is on the chat message, and this chat messages property is the other end of that chat property on chat messages. The only other thing new here that we haven't covered yet is this order by. So we always want our chat messages in this relationship to be ordered by ID. So we're always getting the proper sequence. So when we serialize the chats, the chat messages of that chat will come in the correct sequence. That's going to be helpful for our front end. Chat summary, same stuff, right? We have a chat summary that points to a chat, and this chat summary property on chat is the other end of chat summary.chat. Serialize rules, we're not going to include chat summary. We're also not going to include the second order of chat. So we are going to include users, we are going to include chat messages, but we're not going to bring in that relationship again, because again, it would infinitely recurse. So don't bring chat in again from these other relationships, because we're serializing chat. We wouldn't need that. Same thing here, string representation. Chat user, we already covered. Chat message is a little bit more complex. We've got a class method here just as a helper that we're also going to call from a property. All this does is it takes the data for this record and return it in a format that the API spec would anticipate. So if we take a look at OpenAI, we can see messages is going to be a JSON object that has role and content, and that's it. Similarly, Ollama does that as well, role and content. So this is just a helper method on the class itself, and there's a reason why it's on the class, that we can just call pass in the role, pass in the content, and get this object back. Body is pretty straightforward, nothing too fancy there, it's just a text. Role, as we talked about, is an enum, so enumerable. So we're just saying it can only be one of these types. So if we take a look, right, it can only be one of those types. Then, and actually that's one of the reasons why Postgres is helpful, because it has support for enums along UUID and JSON and a bunch of other nice handy features. So chat summary. Again, the ID lives on the chat summary, so this is the other end of that relationship where a chat summary points to the most recent chat message or last chat message. So that's what this is. It's the other end of that. And then we've got some foreign keys here for whatever chat this belongs to and whatever user this belongs to. And we've covered these. And then again, we're not going to pull in the chat message again when it gets serialized. So infinite recursion. We've got our string representation, and then we've also got this as LLM format. So what we're doing here is we're calling the class method that's just going to return this dictionary. And we can call it from the class itself if we're not operating on a record. So in theory, we could call the class chat message, convert chat message to LLM format, pass in the role and content, get this back. Or we can call it on an individual record. So chat message 1 dot as LLM format and no args, and it would return it. This is going to be helpful. This is for convenience. This is for when we're constructing the system message that actually isn't a message saved to the DB. So it's just helpful to have this on the class so we can kind of keep our code consistent. Chat summary, nothing much fancy here. Again, some foreign keys where we're saying that this is the belongs to this chat. It is a chat summary up to this message ID. Right, so the last message just means that it's up to this message and serialize rules. And that is all of our models. Next, what I want to take a look at is our migrations aren't really anything fancy, right? We're just using that package to create the tables, so we're not going to deal with that. What we are going to do is take a look at our CLI commands. And actually, this is brand new, so we don't need to look at the diff. So we're creating a couple CLI commands here. Again, we just want to be able to seed the DB. So we have a DB seed command. It's going to check if the user in chat already exists, and if it does, it's going to skip it. So it's idempotent. If the data has not been seeded, we're going to go ahead and create the test user, create the test chat, wire them together, and then save it to the database, and then you're good to go. And then we also have, you can see here, we have an app logger. So this is just a simple logger using the Python logger and then also using some of the Flask wiring. All it's going to do is just allow us to write to a log file so we can see when things happen, and then also our LLM messages. This is helpful for development when you're generating summaries or just anything to kind of see what's actually being sent to the LLM. And if we take a look here at app.log, you can see that, so we're seeding the database, we're sending some empty messages to prime the LLM. So we've just got a nice little log message here. And if we wanted to, we could call the clear logs command to truncate that log file. And before we dive too much deeper, let's take a look at how that's all wired up. So to do our CLI commands, we are just going to register. Well, actually, that's part of our CLI class. So this command is just going to register some Flask commands. And the way it's structured, it's just so that we can put it in a separate class file. So then when we're in our app context, we can register the CLI commands from here. So with app context, call this function that then registers it. And our logger, similarly, it's in a separate class file, but it's going to use the standard rotation. So we're just going to tell it what directory, what file to use. We're going to make sure that that directory exists. The file doesn't have to exist, but the directory does, or else it'll throw an error. So make sure the directory exists. We're going to set our log level, which is almost certainly going to be info. It can be overwritten, but for now it's info. We're going to call this our app logger. We're going to use this for our format. So it's going to be time, whatever name, level name, and then the actual message. We're going to rotate it out. So in this case, we're going to keep 1 meg of content and then rotate it. And that's pretty much it. And we can see this is how we're registering it. Down here actually is how we're registering it. So that's how we register CLI commands for our Flask app and set up a simple logger. There's a lot of stuff in the diffs that we don't really care about. So for example, any of the existing code, we'll take a look at data loader, for example. The only thing that really changed was just adding proper type hints. So we don't really need to cover that. What we do want to cover though is going to be our chat stuff. So let's go ahead and fire this up. We should already be. Let's take a look here, do a refresh, and we can see our UI is a little bit different. So we've got our user here that we can't log in and out of, but they're there. We've got our chat here that we're not going to bother swapping in and out. We could truncate it. And we've got chat messages. Let's disable summarization and RAG real quick though. We don't want to dive into that just yet. So if we take a look at the diff for app, we're importing our database, our models, we've got our app logger, and our chat manager is going to be new. So again, this is all scaffolding, and app is from our DB, registering the commands. Get user and get chat is It's just going to be some simple boilerplate. Again, if we wanted to do user and chat management, this is how we would swap it out. But for now, we're just always going to get user 1 and chat 1. And chat manager is just a helper class to take some of the logic out of the controllers and into a separate place and keep it out of the models as well. When I was working on Rails apps, I found that the active record callbacks would get a little bit messy if you started having too many interdependencies. So what I did instead was I would take the business logic and put it into a separate, I guess they call it a command object, where you would have your business logic exposed that way. So instead of having, users and chats, the models directly kind of fire off the sequences where you create a user and that creates a chat and a callback, or vice versa. You instead just have a function that you can call where it's like create user chat. And then in there, you're doing it. And that way, if you ever need to work with the models directly without invoking that business logic, you can. And then you would just walk through that command class to do the business logic. So, yeah. All right, so let's take a look here. Index, we're going to get the user, we're going to get the chat history, and we'll pass that in. And then when we do our prompt stream, this is in fact a little bit different. So likewise, we'll get our user, get our chat manager helper. And then when we send to this prompt stream, we're going to create a chat message, save it to the DB. And then we're going to get back the response and through our chat manager, because the chat manager is going to do some stuff in the back end. So like I said, let's turn off RAG and let's turn off summarization. So if we take a look at our chat manager class, like I said, this is just a class to kind of wire up some of the data business logic. So if we collapse all of this, we can take a look at the shape of it. We've only got a few methods here that we care about right now. We're going to create chat and user, delete chat messages for chat, create chat message, get the LLM response and save messages, and then format chat messages for LLM. So create chat messages and add user. Nothing too fancy there. Pretty standard stuff. We could probably get away with doing this in the controller, but again, I just think it's nicer to have it tucked away. Not to cause indirection, but again, just make it nicer so that your controllers are pretty light. Delete messages is, again, pretty simple. We're going to have an endpoint, and that's going to correlate to this clear chat where we just call this. So if we take a look, we have a HTTP delete. So for chats, ID chat messages, because we don't want to delete the chat, we just want to delete the messages. We're going to delete messages and then return a 204. So we're going to look for the chat summary where it belongs to this chat. And then likewise the chat message where it belongs to this chat, and delete them. And that's it for that one. So that's how this works. We'll demo that in a second. So the meat of this is going to be create chat message. One more thing is very simple as well. So we're just creating the chat message and committing it. Again, probably could be done in the controller, but we're packaging it up nicely here. So the get LLM response stream and save messages and format messages for LLM, this is where the meat of it's going to be. So let's change two things. We're going to turn off summarization, just to start simple, and we're going to turn off RAG. We'll get into why RAG is complicated in a second, but for now, let's turn off RAG. Should be, if we go into our LLM client, and actually, if we look at the diff for the LLM client, nothing too fancy there. We've just added types. We're passing in our logger. We're passing in a debug flag. If the debug is true, we're going to log the responses to the LLM, which you saw prior. We're going to set the temperature lower in an attempt to make RAG work a little better with this. We are going to add a summarization prompt that we call to the LLM. So the LLM, not only is it going to respond to us, but we're also going to make the LLM do the summarization. The existing methods are all the same. We're just adding a flag for whether or not we want to use RAG, and we're adding some logger. Keep alive is an OLAMA property that keeps the model in memory. By default, I think after 5 minutes or so, it'll offload the model, but for our purposes, we just want to keep it alive. So yeah, we can see here we've got a flag for use RAG. Response stream, same deal. This is the new one. So previously, we were just working on an LLM response, and we were not using any chat history. So the arguments we're passing in now are going to be a little bit different. So if you remember from last time, we were calling generate, we were passing in a prompt, and that was a single prompt. For chat, what we have to do is pass in an array of messages, a list of messages. So you can see here, we are going to do things a little bit different because we could also pass in the system prompt to .generate. And for this, for chat, we have to construct it ourselves. So we are going to take our messages that we send in. We're going to prepend the system message. So let's say we have a list of messages that says like, hi, and that's it. So when we get that array that says hi, we're going to prepend the system message, whatever it might be. And then if we're using RAG, the last user message is then going to get recreated with that RAG template. So instead of just the simple prompt where it says hi, it'll say, using the retrieved context, answer the user's question, context, and then, the document. So if we are using RAG, it'll replace the last message in the list with a ragged up version of it. And then we're just going to log it. So for system, we're prepending, and for use RAG, we're replacing the last message with a ragged up version of it. And then after that, it's pretty simple, right? We're just calling .chat instead of .generate. We're going to pass in our options. In this case, it's the temperature. We're going to want to stream it, and we're going to pass in our messages. And then we're going to return the output as a generative function. So you can see here, prepend system prompt, pretty simple. We're taking a list, we're returning a list, and all we're going to do is take our system message, and in this case, we're going to pass in the system role and the system prompt that we set in our constructor. And that's going to look like this, prompts system. So it's going to take this as the content. So it's going to be an array, right? So it would be role system. And then the content would be you're an assistant for question answering tasks. And go back to our diff. So to prepend it, right, we're just going to generate this. We're going to use that class method again on our model. And again, the idea there is we're not implementing it both in the LLM client class and our ORM record. So by having it as a class method, we're able to call it here without re-implementing that logic in two places. So we're just going to get this back, and then we're going to insert it at the very top. So this is how we prepend. And then for our last, replace the last message with the RAG version, all we're going to do is take the content of the last message, so not the role, just the content, and then we're going to run our input. So whatever the content of that last message is, maybe it's hello, looking at the API docs example, say it's hello, and then we take a look at the prompt. It would get replaced with this. So instead of hello, it would be use the following passages to help respond, blah, 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 blah. And then message would be hello. And so that's all it's doing. So prepend replaces, or prepends, obviously, puts the system message in the very top of the stack, replace render last message with RAG, replaces the last message's content with the RAG prompt version. And that's pretty much it. We'll get into the chat summary in a little bit. Again, we'll start somewhat simple. And then log messages is just a helper that we call from all of these. And it's going to say if it's debug, allow it to log out. And then we can see what some of these look like. But we do not want summarization. So we are on debug, but we don't want summarization. So we've turned off summarization here. And then for this LLM response stream, it's a use RAG is false. Okay, and with that, let's just double check. See what other calls we have here. Yeah, so if you use summaries, so this will go away. And that should be it. So yeah, so let's take a look at what we're doing here. So when we call get LLM response stream and save messages, we're passing in quite a bit, but let's walk through it. So right now, when we get the LLM messages, they're going to be in the format from our ORM. Messages, right? Because we know what chat we have because we load that up. And then we're going to create a new chat message. So if I were to say hi, we're going to create that chat message, save it to the DB, and that also adds it to that chat object. So we're passing in the chat messages as ORM records, not in the format the LLM expects. So the first thing we do is convert these ORM records into the LLM format. And all that's going to do is iterate or map over them and call that as LLM format. And then that just basically takes the existing list and then replaces them with that as LLM format, which is again just going to be role content. And we're not using summaries right now, so we don't have to worry about this. So we're getting our LLM messages in the right format. We're then going to send those off to our LLM and get the response back as a string. So this bit looks a little funky, but we're doing our stream as before. So this chat manager is taking the generator response from the LLM client class and mirroring it. And then at the very end of it, we want to capture the full response and save that as a chat message. So that's why it looks a little bit funky. If we weren't using a stream, it'd be really easy to just get the response from the LLM and save it as a message. But since we are streaming, we have to create kind of like a buffer, right? So we're creating a string here. We're going to get the response from the LLM client stream. And as that's going out, we're going to append it to our string here and then also yield it, which will then go to our controller, which will then go to our JavaScript client. And then at the end of it, we take the full response, clean it up, and then save it actually as a chat message record in our DB. And we're doing the assistant role. We're saying belongs to that chat. Because the connection has closed, at least in my quick debugging, I had to interact with the DB a little bit differently. Normally, you could just use the ORM as is, and you could do, DB session append, commit. I think because the app context had already closed, because the generator stream has closed, I had to wire it up a little bit differently. So here we're creating the engine manually using our DB URI that we pass in. So that's just going to be our config property. That's the string that says Postgres : / / blah, blah, blah. And then in the session, we add the chat message response and then commit it. And then we're not caring about summaries right now. So let's go ahead and take a look. So no RAG, no summaries, and let's see what happens. So we've got this, and if we go over here, refresh, we're using phi3, and let's see, hello. And it's coming back with some stuff. Because our system prompt is you're a question answering assistant. That's why it's doing this kind of stuff. And actually, let's take a look at our app log. Yeah, so we've got empty responses to kind of prime the LLM. We've got our DB seeding. And then, yeah, down here, we've got the system message that we sent off to the LLM. You're an assistant for question answering tasks, blah, 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 blah. And the user is hello. So this is what we're sending off to the LLM, and we can see it in our log here. And then let's take a look at our DB real quick. So if we take a look now, previously our chat messages were empty. Now, if we take a look at our chat messages table, we can see we've got our responses saved here. So this and this. And we can see it belongs to this user, this chat. We can see the role, again, correlates properly. And we can see it's captured the response. So the other thing we're doing here that's a little bit different is we're passing in the state from the server side. So if I do a hard refresh on this, it didn't look like anything changed. So if I do it like this, we can see that it renders it right away because we're passing that in server side. And this is our chat history. So because we're remembering things, I'm going to say this. Please remember that I like to eat pizza. Let's see what it says. And yeah, so again, it's trying to be a helpful question answering bot. So it's really obeying that system prompt, almost malicious compliance, actually. Joking aside, it's going to come back with 3 examples. We'll let it save. You can see the stream still open. And once this stream ends, we'll be able to take a look at the DB. So now, if we go back to our chat messages and refresh, we can see now we've got, please remember I like to eat pizza. Absolutely, if you're interested. Okay, so it's in our DB. Cool. Why does that matter? Well, if we do a refresh, and again, it doesn't look like anything's changing, but I promise you it is. Now we're coming back to it, and I can say, what do I like to eat? Yeah, and you can see it remembers me now. So very simplistically, this is chat memory management, right? So we've got our DB set up here so that we can save these messages and associate it with the user. And then we're just able to put that in the right format and send it off to the LLM. The problem, though, is eventually you're going to run out of context. Since we're passing in these chat messages, actually anything you pass in, including the output, is going to count against your context. So one strategy that you can use is chat summarization. Now, in our simple setup, it works, but I will say that with just doing CPU, it's really kind of, you're getting towards the limit of what we're able to accomplish with this hardware. But nonetheless, let's take a look and see what it can do for us. So if we go back into our chat manager, we're not going to use RAG just yet. We're going to turn on use summaries. So now what will happen is after, well, 2 things. When we're formatting our chat messages, if we are using summaries, what it's going to do is replace any messages in the message is array or list that are at or before the chat summary with the chat summary. And then any messages that are after the summary just get sent as is. Keep in mind, we don't want to get rid of this chat message history with the summary altogether. We want to keep these messages because when we're interacting with the chat, we want to see what was actually said. And also that allows us to regenerate the summary if we ever needed to. So we're not getting rid of the chat message history. We're just creating a derivative that allows us to kind of optimize our LLM calls. So you'll see in a second. So we're going to, when we're sending it off to the LLM, any messages at or before the summary high water mark get replaced with the summary. So hypothetically, if we had a summary that said was at this message ID number 4, so where it's talking about pizza, but not 5 or 6. So let's say the summary is at message 4. Summary would be something like, the user wanted to remind you that they like to eat pizza. Chat ID 1, last message ID 4. And then what would happen is when you send it off, the messages array would look like this. It would be system prompt is the first one, then the summary, and then what do I like to eat based on our previous conversation. So that's when we're sending it to the LLM. We're going to replace any messages that are relevant with the summary. And we're, again, just going to format this. And for now, we're just doing a simple content where it's like, here's a summary of previous messages, and then the chat summary content. And we're pretending that's a user message. And then we're doing some list comprehension to jam those together. The response side, what we're doing, so that's the same. All it's doing is, again, just swapping out the summary. On the response side, after we save the response message, we're going to kick off a call to the LLM again, although this isn't user-facing, to then summarize the conversation. So the idea is you're potentially taking context or conversations that could be long-running, and you're compressing them down to what's hypothetically useful. And because this is done as a derivative of the chat history, in theory, you could do this asynchronously in, non-blocking or what have you. This is not a fully fleshed out implementation. Again, we're just using CPU, so it will be blocking, but in theory, you could do it non-blocking in a separate process. And then whenever it's available, you have the pointer to the last message, so it can just kind of take over. So what we're doing here is after we create the response message, and again, in theory, you would do this non-blocking, but we're going to do it blocking for simplicity's sake. Concept's the same. We're going to get the chat summary from the LLM of all these messages. So we've saved the response message from the LLM, and then we're going to send it back again to the LLM to then summarize it. And what that looks like is pretty simple. So we're going to have a new summary prompt. So we're calling generate because we don't care about message history. This is a self-contained call. So we're going to have a summary prompt where we're just telling it, here's a list of messages. Yeah, so you're a summarizer, keep it concise, coherent, prioritize clarity, brevity, make sure it's self-contained. And then we're just going to pass in those messages, and then it's going to spit out the summary. And so we're calling the LLM again, and we're having it do the summary in the background. And that's not going to be sent to the user. This is just for our own purposes. Then once that's done, if we already have a summary, if we don't have a summary yet, we're going to create a brand new summary record in our ORM. Or if we do already have a summary, we're just going to replace the body with whatever the LLM spit out. And we're going to update the last message to point the most recent message. So if it was message 4, now it's message 6. So you're updating both of those. And then you're just going to commit that. So it's either getting created brand new, or you're updating the body and the last message. So that's the strategy. So let's take a look at this. And we have summary turned on true. Let's just do a hard refresh for giggles. And actually, as I mentioned, we're pulling in the state server side and we're passing it. That is kind of interesting. Well, we'll get into that when we take a look at the JavaScript code. So let's see what we have. So what do I like to eat? Pizza. Let's tell it something else to remember. My second favorite food is burgers. All right. So it's going to be a little bit slower this time because we're going to kick off the response, and then we're also going to get the summary back. And again, that's in a blocking fashion. So it's coming back and it's talking about trying to be helpful as always. And the response is done, but you can see here, it's still loading because we're generating that summary in the back end. So that's going to be another call to the LLM. And this is going to take a little bit to generate. Once this loading spinner goes away, we'll know that the summary is completed and we can take a look at the back end data. Okay, our loading spinner is done. Let's take a look at our DB. So we can see here, our new messages are in there, second favorite, that's great to know. And then now, if we take a look at our chat summary, so we can see the last message was message 8, that makes sense. And here is the summary. Let's actually do a quick look. So the user expressed their preference for eating pizzas and burgers as favorite foods. Interest in, they also showed curiosity about burgers. And yeah, so this is a summarization of the conversation. What that means we can do now, hypothetically, if we're running out of context, because we have summarization turned on, we're going to send a message. It's going to become message 9, and then anything before it, 1 through 8, is going to get replaced with that summary. So what are some of my favorite foods? Again, the user is seeing the full chat history because we're displaying that as is. What the LLM is seeing now is that summary plus new messages. So let's send that off. And we can see we got a response back. And it says, your favorite foods include burgers and pizzas. Pizzas and burgers. And it's leaking that this is a response based on a summary. That's fine. Again, we can tweak the prompts later, but hopefully this gives you kind of an idea of how you might approach the constraints of a limited context window. So again, you're using not only the LLM to answer the user's questions, but now we're starting to get into the waters of having the LLM do tasks in the back end for us. Generally, we're going to need more compute to do this properly. You can kind of see here that our response streaming, we're not getting very many tokens, and we're not running a particularly large model. So as we get more sophisticated and more complex, we're going to need more hardware to be able to run a more complex model that can then get the responses back quicker. But conceptually, this is a strategy for handling long-running messages. But the nice thing is, we've still got the full message history. So in theory, we could regenerate the summary. We could, not use the summary. The summary is a derivative of the conversation. It's not the, source of truth. So we can always just, turn that off, regenerate it, do what you will. So the last piece we're going to cover is RAG. Now, I'll say that you can sort of get chat message history and RAG running together in a simplistic fashion, which is what we're going to take a look at. But realistically, they don't really play nicely together, just jamming them together. You're kind of doing two opposing things. Not directly opposing, but you've got RAG, which is you're saying explicitly use this context to answer this question. And then you've got the chat message history, which is in itself context. So now you've got these two weird dynamics where you've got RAG, context, and then chat message history context. What you would probably want to do is use another LLM call to negotiate that and try to figure out how best to pull what from where, as opposed to just jamming it all together and sending it off and hoping for the best. We're going to do jamming it all together and hope for the best because, again, we're on CPU and we're just getting started. Just to kind of show you that it kind of can work, but later on, we'll get into the real sophisticated stuff. But for now, let's just jam it together and see what sticks. First things first, though, let's clear the chat history. So we're going to clear the chat. Chat was cleared, and that did all the DB stuff. So now we're totally cleared out. And let's turn on RAG again. So we can actually just get rid of this because it defaults to true. And our content is not there. So let's add a document. Matthew Haynes, also known as Matt, a coder and YouTuber that teaches web dev, AI, and machine learning. Document. Okay, all right, so now if we do RAG, let's do a refresh. Let's tell it something, and then we'll see if we can retrieve the context, which should say something about being a YouTuber. So my favorite food is pizza. So we're doing chat message history and RAG. So it came back with just a general answer, because it's supposed to be a question answering robot. And it didn't have a source for that. Makes sense, because the only thing in our content should be about me being a YouTuber. So once the summary's done, we'll take a look at the back end. Chat messages, pizza, chat summary. Summary in this case is heavy on the pizza, and it talks about the user's preference. So you can see here we're starting to get into, because there's the RAG prompt, it's starting to clash a little bit. Nonetheless, let's keep it rolling and see what happens. So I did a hard refresh. It should know my favorite food is pizza. What is my favorite food? Yeah, okay. So this time it wasn't able to quite do it, partially because probably that summary's clamping in here, which is where, again, this gets a little bit funky. If I were to turn off summarization, it could probably work. But let's just do one last thing, and then we'll turn off summaries, so it uses the full history. So we're going to say, what does Matt do? Because it should say something about Matt being a YouTuber. Let's see what it says. So this should be our standard RAG. Yeah, and you can see here it's bringing up the standard RAG stuff. So, and it's sourcing it appropriately. So let's try turning off the summaries, because again, the summary is going to replace the previous messages, and see if that works a little bit better. So we're doing with RAG, but no summaries. Save. Do a refresh. It's still churning. Maybe we'll give it a second to see if it can run through. Okay, so last message ID is 14. And yeah, so we killed it before it did the summary, but that's fine. All right, so it should say my favorite food is pizza in the history. This is maybe gonna throw it off, and it's talking about what I do. So let's do a hard refresh. Let's try asking again. What is my favorite food? So we're not using the summary in this, we're just using the raw message history. And the food isn't in the RAG context. It's only in the chat history, unlike this bit, which was from RAG. Yeah, okay, so it's a little bit better this time. Because the summary was omitted, and the summary can compress and collapse, and it gets a little bit funky when you're trying to summarize the RAG responses. But without the summary, you can see it worked a little bit better. So it says, seems to be pizza based on the information provided earlier. So that is message history with summarization, message history with RAG and summaries. And again, on our current setup, we're starting to hit some limits. So we'll get there though. We're getting there. We're exploring the concepts, and I think you can kind of see where this is going, and we'll work through it. Let's do one last thing, and then we'll go ahead and wrap up. So let's take a look at some of the implementation details we glossed over. So we already covered all the Python stuff. So I think the only other things we really need to cover is just the JavaScript code changes. Those will be quick. They're really minor. So the most notable change is how we're passing in the data. So if we take a look here in our app file, and we take a look at the index, what we're doing is we're serializing the chat to JSON, and then we're passing that in to our template. And then if we take a look at our template, we're actually going to pass that in as a data adder, the actual chat JSON. So if I were to do view page source, and we can see here, this HTML element has the JSON passed in as a string. Why that's helpful is when we boot up our Svelte component, we can parse this out and then pass it in as a JSON, well, as a JavaScript object. And then that way we're not needing to make an initial HTTP call, right? When we render this, we already have it, and we can, just go right off the bat instead of saying, empty initial state and then going off to the server doing a second request. So that's what's going on here is we're literally encoding the JSON in the template and then just having our JavaScript parse that. So that's one thing that we changed. The other things we've already covered, so there's not much else there. And then in our JavaScript, our Svelte, we did a little bit of code cleanup. I don't think there's really much here. You can see set initial state. So all we're doing is we're just iterating over that object and setting it. So there's nothing really new, novel here. There is the clear chat, but again, that's just going to fire off a HTTP delete and, some template changes. And then we've got a little bit of changes here and there. And that's pretty much it. So the most significant thing that we've done is, again, pass in that state from the server side into our component on render, as opposed to doing another HTTP request. So that's chat history, another one in the books. I think that's all I have for you today. We'll see you on the next one, and thanks so much for watching. You just passed? No. Get into that shortly. Implementing. What if you have multiple chat message history, message. Current user. Both of alchemy. Using Svelte LLM calls.